Hey, welcome back to Math 103 College Algebra from Central Connecticut State University, Section 3. Functions and their representations. We're going to look at some basic concepts, including domain and range. Some of this will make sense during video this way. Honestly, a lot of this is better done one-to-one or live and in person, but we'll do the best that we can. We're going to first start by talking about domain, domain and range. And the basic concept of domain and range is something that I wrestle with teaching because often when we talk about domain and range, we talk about them in context of in an Algebra 1 class, in an Algebra 2 class, where we're dealing with linear functions and quadratic functions and various polynomial functions, even maybe exponential functions where the domain is always all real numbers. And so it gets a little confusing as to exactly what it is we mean by the domain and range. For now, we're going to say that the domain is the set of values that can be utilized, substituted in for the independent variable. And again, I'm sorry for my messy handwriting, but the domain is the value of x. What values can I substitute in for x? Sometimes we will call that the input. What are those values that x can equal? The range is the set of values for y, or that are the result. Let me fix that. I'll spell correctly, even though it's not the neatest writing. That are the result of substituting the x value. In other words, that would be the output. Okay. In a previous, let me switch to a different screen here. In a previous video, we talked about you have a job, right? My son has a job and he makes $18 an hour. So y is equal to 18x. So x is the input. The domain would be the values that x can equal, the input. Now, if I think about that, if he's working up to 40 hours a week, x can be anywhere between 0 and 40 because he's not going to work fewer than 0 hours. He's not going to work more than 40 hours because his boss is not paying for overtime. So the values that I can reasonably substitute in for x is any value between 0 and 40. The values that y can equal, well, let's think about this. If x equals 0, y is 18 times 0, which is 0. If x equals 10, so 10 is a value from the domain, then y would equal 18 times 10, or would be $180, okay? All the way up to a maximum of 40 hours a week. Y would be 18 times 40, so that would be 720. So these values that I'm getting for y, those are the output values. Those are the values in the range. So the range is the values that I get for y. Those are the output values. Okay, in this case, y is always going to be between 0 and 720, and so that would be my range. Okay, so that's one way to look at domain and range. Representation of functions, I can describe them verbally. I can talk about what I just said. My son is making $18 an hour, and so for each hour he works, he's going to make $18. Okay, so that would be a verbal representation. I can give a table where x and y, if he works 1 hour, he makes $18. If he works 10 hours, he makes $180. If he works 20 hours, he makes $360, and so on. And I can have a table of values. The formula that I've been using, f of x equals 18x, that's a formula. okay? An equation, f of x, right? The y is f of x, so my f of x is the y values. So this is the same as writing y equals 2x plus 5, y equals 500 plus 0.15x. The reason that we like writing that with the f of x notation is, come back over to my son, that if he works 10 hours, 18 times 10 is $180. So f of 10 equals 180. You notice you see both the value from the domain, the 10, and the resulting value from the range of the 180. In formula A, if I have f of 2, that's 2 times 2 plus 5, or 9, and I can do that substitution. With a graph, I can represent a function by drawing a graph. Okay, now something that's important about a function is a function is or a relation is a set of ordered pairs. So anytime I have a set of ordered pairs, I have a relation. Here's a bunch of values for x, here are corresponding values for y. That's called a relation. What makes an equation or a relation a special case called a function is that each element in the domain has exactly one element in the range. The same x value cannot give two different y values. Again, if you have a job and you make $18 an hour, f of x equals 18x. If I work 20 hours, I'm going to make $360. For that value of x, there's only one value for y. Okay, and again, we've talked about domain, we've talked about range. I will talk about them again some more in a little bit. When I look at the graph of a function, if I have something that looks like this, then I know that I have a function, because of each value of x, there's only one value for y. What a lot of people will talk about is this thing called the vertical line test. Can I draw a vertical line anywhere that will cross this function in more than one place? Because I can't, then yes, this is a function. Now, I'm not going to write this down because you won't have to read it, but this graph that's become a mess in the blue, this is a function not because it passes the vertical line test, but because each element in the domain corresponds to exactly one element in the range. For each x, there's exactly one y. If I look at a function that looks like this, actually I look at a graph that looks like this, that is not a function. Notice that if I try to draw a vertical line, I can draw a vertical line, meaning for one value of x, there are multiple values for y. Therefore, this is not a function. It's not a function. The reason that this is not a function is not because it fails the vertical line test. That's how I know it's not a function. This is not a function because I have a value of x that has multiple y values. So that's not a function. Okay. Let's move on to some notations. There's set builder notation, and there's interval notation. In set builder notation, we always use set notation. The set of x values such that x is equal to 4. What you'll notice is that for each one of these expressions, to put that in set builder or set notation, I'm simply going to add what I call the template, the set of x values such that, it's a vertical line, x is between 2 and 7. X is between -3 and 6, including the -3, not including the 6. X, 4 is less than x is less than 9, so x is between 4 and 9, but not equal to. And really, I could sit here with the set builder notation for all of these, but you'll notice essentially what I'm going to do is I'm just copying x is greater than or equal to 4, x is less than 5, x is less than or equal to 5, x is not equal to 7. In each one of these, and around it, I'm just going to write the set of x values such that the condition is met, that x is less than 5. Okay, the set of x values such that, that's a pretty ugly brace there. Okay. With interval notation, things are a little bit different. Okay. And I'm going to do these out of order, but with interval notation, whenever you have a equal to, less than or equal to, greater than or equal to, you're going to use brackets. Whenever you have just a less than, you're going to use parentheses. So you'll notice that the second line here, x is between 2 and 7. My interval goes from 2 to 7, including the 2 as well as including the 7, so they both have brackets. Skipping 4 is less than x is less than 9, we have all the x values on the interval from 4 to 9. However, we're not including the 9, nor are we including the 4, so we use parentheses. Okay. Let's get rid of these things and keep track. For this guy here, we have the interval from -3 to 6. We don't include the 6, so the right side of the interval gets a parenthesis. We are including the -3, so the left side gets a bracket. So if I go back and look at the first one, we only want 4. We're including it, so it's simply 4 with a bracket. I don't know that I would bother to put that one in interval notation, but that's how I would do it. For these groups of numbers, intervals, that are one-sided intervals, actually, let me not include the last one, but for these 4, notice that x is greater than 4. So we want to go 4 all the way to the far right, which means we're going to go to infinity. We're not including the 4, and you never can include the end of infinity. So the infinity will always have a parenthesis. The next interval goes 4 all the way to positive infinity. Again, you never, ever have a bracket on the parenthesis because you can't get to the end of it. However, we are including the 4, so we have a bracket. The next two, with x is less than and x is or equal to 5, we're going from the 5 all the way to the left or toward negative infinity. Negative infinity. Same thing, always a bracket. X is less than 5, we're not including the 5, so it gets a parenthesis. When it equals the 5, you can get a bracket. Okay. For x is less than -3 or x is greater than or equal to -6, you're going to write that with 2 separate intervals. Negative infinity to -3, comma, that should be a bracket because we're including the 6 to positive infinity. So that takes 2 sides of that. So to back up to x is not 7, I would go from negative infinity to the 7. Notice parentheses on both sides because I can never get to the end of negative infinity, and I'm not including the 7, comma, from 7 to positive infinity. Sometimes I'll be asked which notation is better, the set notation or the interval notation. And quite honestly, I don't have a strong opinion one way that one's always better than another. In my opinion, it depends on how difficult it is to write, and I tend to want to use the simplest notation. Often that's the interval notation in my mind, but for this one here, I think I would rather use the set notation than the interval notation. Okay, and then again, that becomes a matter of preference. In my course, I'm not fussy. I don't say which notation to use. What I'm fussy about is that you use a correct notation. Lastly here, from negative infinity to infinity, again, set notation. I have the set of all x values such that x is between negative infinity and infinity. That just means that if I look at the number line, I'm going from all the way left to all the way right. In interval notation, you're going from negative infinity to infinity, and you include the entire interval. So that's a quick synopsis on set builder and interval notation when we come to look at things. And we'll use that again in a minute when we talk about domain and range. Before we do that, I want to talk about evaluating functions. If x equals 0, evaluate the function, number 1. f of 0 would be 2/3 times 0 plus 4, which is simply 4. To do x equals 2, f of 2 is 2/3 times 2 plus 4. This is a little bit more complicated only because of the fraction. 4/3 plus 4, which is 12/3, is going to be 16/3. Now, if I want to use the calculator, I've got it sitting over here, haven't used it much. 2/3. Let's go back and put parentheses. I forgot to put a parentheses. I can hit second insert parenthesis, and that'll put that in there. 2/3 times 2 plus 4. And notice we have 5.3 repeating. I think rewriting that as the fraction is better. So that would be 16/3. Let's use a green here. X equals -3. F of -3 is 2/3 times -3 plus 4. 2/3 times -3 is -2, plus the 4 is a +2. And so you can see that this is really not that complicated, I would hope. Let's go purple. X equals A. This will be the easiest one so far. F of A is simply 2/3 times A plus 4. There's nothing to simplify, so it's just the 2/3 times A plus 4, and then you've done that. This guy, let's go orange. What if X equals X plus H? It's not going to be F of X this time, right? We're replacing the X with X plus H. So that's going to be 2/3 times X plus H plus 4. At this point, initially, if you can do that substitution, that's a good start. What I encourage you to do is to go ahead and try 2, 3, and 4 doing those substitutions. And I'm going to pause the video, or you pause the video, and let it see what you can do with these, and see if you can do those substitutions well. Okay, so I've gone ahead and jumped ahead, and I've done number 2. Something I want to point out in number 2 is, notice here, -3 squared. Make sure that you put that in parentheses. And I want to show you something here in the calculator. You need to be sure that you put the -3. Now, I'm hoping all of you know that -3 squared is going to give you a +9, because that means -3 times -3. If you simply type in -3 squared, the calculator is going to do the problem correctly and give you -9. The problem is you need to recognize what happened. You did the opposite of 3 times 3 and did not square the negative. So make sure that you include, especially if you're using a calculator, that you include those parentheses, okay? For number 3 and 4, I'm not going to take the time in this video to do all of the substitutions, but I'll do a couple of key ones. For example, let's do f of 2. 2 times 2 plus 3 divided by 2 minus 5. So 2 times 2 is 4, plus 3 is 7. 2 minus 5 is -3. I think it's better to make that -7/3 and either put the negative up with the 7, or you could put the negative in front of the fraction and make it a negative fraction, or a fraction with a -7. Either one is the same. The other one I do want to do at this point is the X plus H. I'm going to replace the X with the X plus H. Okay, and then I'm going to say that's 2 X plus H plus 3 over X plus H minus 5. Still a good idea to leave that in parentheses there and just do that straight substitution. Okay. I do want to spend a little bit more time with number 4. F of 0 is the square root of 3 times 0 plus 6, which is the square root of 6. Because the square root of 6, look at the calculator here, the square root of 6 is an ugly number, we're okay just leaving that for now as the square root of 6. I do want to look at f of negative 3. The square root of 3 times negative 3 plus 6. Negative 3 times 3 is negative 9 plus 6, so I have the square root of negative 3. And we're taking the square root of a negative number, which right now we can't do that at this point. We'll talk about those later in the semester, later in this course. So at this point, when I'm working with real numbers, x can't be negative 3. I cannot substitute the negative 3 in for x and get a real number. I'm going to get an imaginary number, and again, that's coming later. So with that, I want to move on to domain. What is it I mean by domain? Okay. Determine the domain and the range, and predominantly for this video, I'm going to focus on the domain. When I think of domain, I think of allergies. If we think about a food allergy, let's suppose we're going to have a get together, and I say to people, you know what, I'm going to have a group of people getting together, and I need you to, because I'm going to serve food, I want you to make a list of all the foods that you can safely eat. Not asking what you like or don't like, but what can you eat? That would be a very long list. Most people might say, I can eat anything except I can't eat dairy. I can eat anything except for shellfish or not peanuts. It's a lot easier to talk about what X can't be. I'm going to skip numbers 5 and 6 for a moment, and I'm going to show you that, focus on 7 and 8. What if we were to do, and I think I'm going to move to my other screen to do number 7. Where we had f of x, I'm going to go back and forth to make sure I copy it correctly. F of x is 2x plus 3 divided by x minus 5. I should be able to do the same exercise I was doing before. What if we do f of 0, and I'm going to put 0 in for x. So that's 2 times 0 plus 3 over 0 minus 5, and I get negative 3/5. I could do f of 1. What I want to focus on is what if I try to do f of 5. 2 times 5 plus 3 is going to give me a numerator of 13, but my denominator, I have 5 minus 5, and 5 minus 5 is 0. And I have 13 divided by 0, and 13 divided by 0 is undefined. Now, the reason that 13 divided by 0, there's no solution, it's undefined, is because if I say 15 divided by 3 equals 5, how do I know that? Because 3 times 5 equals 15. 6 divided by 6 equals 1, because 6 times 1 equals 6. 13 divided by 0, if I say that equals some number n, 0 times what number will equal 13? There is no number. There is no value that will work. So that's undefined. X can't be 5. X cannot be 5. You cannot have a 0 in the denominator. So anytime you have a function, if you're going to get a 0 in the denominator, X can't be that value. So my domain here, X cannot be 5. Let me erase this and write it neater. X cannot be 5. For me to write that domain in set notation, I simply write that X is the domain is the set of X values such that X is not equal to 5. And there's my domain. Let's try another one. If f of x equals 3x plus 2 divided by x plus 4, To find my domain, I'm not going to worry about what x can equal. I'm going to worry about what x cannot equal. The denominator, x plus 4, cannot equal 0. Now I'm going to solve that for x. X cannot be negative 4. Set builder notation. The domain is the set of x values such that x is not negative 4. So that is what I call my first domain allergy. So let's look at number 7 again. My domain here, okay, x minus 5 cannot be 0. Adding 5 to both sides, x cannot be 5. My domain is the set of x values such that x is not 5. Number 8, I'm going to go back to my other screen just for more room. Okay. Suppose I have something like f of x, okay, f of x equals the square root of x plus 2. The value that's underneath that radical, in this case the x plus 2, has to be greater than or equal to 0. Subtract 2, so x has got to be greater than or equal to negative 2. As long as x is greater than or equal to negative 2, I'm going to get 0 or greater in the denominator. Underneath the radical. So for my domain, if I use set builder notation, all I need to do again is put the template around. The domain is the set of x values such that x is greater than or equal to negative 2. This one, I might put this one into interval notation because this interval notation is simpler than doing interval notation with just not equal to 4. Okay, so here 3x plus 6 is underneath the radical. So we know that the 3x plus 6 has got to be greater than or equal to 0. Subtract 6 from both sides, and 3x has got to be greater than or equal to negative 6. Divide by the 3. X is greater than or equal to negative 2. So there's my domain. The domain is the set of x values such that x is greater than or equal to negative 2, or the interval notation, bracket negative 2 to positive infinity with a parenthesis. Notice that number 5 and number 6 has neither one of those domain allergies. There's no value of x that's going to give me a 0 in the denominator because I don't have an x in a denominator. There's no value, there's no radical, there's no square root, there's no value of x that's going to give me a negative under the radical. So the domain for both of those is all real numbers. Okay, so the domain is the set of x values. You could write where x goes from negative infinity to infinity. You could use interval notation from negative infinity to infinity. Or you could write the domain is the set of x values such that x is an element of the set of real numbers. X such that x is an element of the set of real numbers. This little symbol here looks like the beginning of an E or a C with no curve to it. Element of, and then capital R with 2 verticals just means real numbers. So I can write that any of those ways. Okay, so there's a little excursion into domain and range. Okay. You do want to learn how to graph a calculator, a graph with a graphing calculator. If you look at the graphing calculator right here in the upper left is y equals. Make sure that plot is off. Whenever you go to graphing equation, make sure that plot 1 is off. And you're going to put the equation in here. So if I want to graph something like, let's go to alpha y equals number 1 to put this in as 2/3 x plus 4, and you hit graph. And my screen was a little wonky from something I did before. Always consider go to zoom 6, and there's the line. For number 6, if I want to graph that, I'm going to leave the first one there. This is x squared plus 2x, and I graph that. And notice that number 6 is in red, and I have that parabola. The calculator will graph the functions pretty well. So you do want to learn how to graph with the calculator. Okay. And again, identifying functions, we're going to save that for a future date, as well as diagrams and equations. So there's looking at functions, domain and range. Again, I hope that that's helpful. I will have a copy of the blank notes as well as completed notes in the description below. Please be sure to subscribe. Thank you.